So this question is by numerical methods. So let's read and see what's going on. The equation 2x cubed plus x squared minus 1 equals 0 has exactly one real root. Show that, for this equation, the Newton-Raphson formula can be written as such. xn plus 1 equals 6x squared n plus 2xn. Well, first thing we want to do is recall what the Newton-Raphson formula is, which will be in your formula book. So the Newton-Raphson formula is going to be xn plus 1 equals xn minus f of xn all over f dash xn, where the dash implies the function has been differentiated. So all we're going to do now is find the different derivative and plug it in. So if f of x is going to be 2x cubed plus x squared minus 1, then f dash x is going to be, well, we times by the power, reduce the power by 1. So 3 times 2 is 6, reduce the power by 1, 3 minus 1, 2, 6x squared. Times by the power for the x squared, 2, reduce the power by 1, 1, so x to the 1, which is just x. And minus 1 differentiated is 0. So now let's plug this in. So xn plus 1 is going to equal xn minus f of xn, which is going to be 2xn cubed plus x squared n minus 1, which is just f of x, all over the derivative, which is going to be 6x squared n plus 2xn. Next thing we want to do is, from the question, we can say we have it all as one fraction. So we want to put this together into the same fraction. And how do we do that? Well, we want to turn the xn so it has the same denominator as this bit here. So we want to times the xn by 6x squared plus 2x over 6x squared plus 2x. So what will be left with xn times 6x squared plus 2x all over, put that as a straight line, all over 6x squared plus 2x minus 2xn cubed, this has just stayed the same, minus 1 all over 6x squared n plus 2xn. And now let's combine the fractions together. So we're going to have xn multiplied by 6x squared n plus 2xn minus, now remember, this minus is around the whole thing. So we can imagine invisible brackets around this top term here. So we're going to have minus 2x cubed n minus x squared n plus 1, as we have minus minus 1, so it's going to be plus 1. As it's minus this entire term. So when combined together, all of this becomes negative. All over 6x squared n plus 2xn. And now, expanding out the first bracket, we're going to have xn times 6x squared n, which is going to be 6x cubed n. xn times 2xn is going to be plus 2x squared n. And this is what we had before, minus 2x cubed minus x squared plus 1 all over 6x squared plus 2x. And now we can simplify the fraction, so we're going to have xn plus 1 equals this simplified. So 6x cubed minus 2x cubed, 4x cubed n. 2x squared minus x squared is going to be plus x squared. And then there are no x's and there's just a singular one. All over 6x squared n plus 2xn. And that's it for this question. And we can check with the top answer to make sure we're right. And we are exactly where we needed. So that's it for this question. In terms of the marking, you'll get 1 mark for getting the final answer. You'll get 1 mark for plugging it all in correctly into the formula at this bit here. You'll get 1 mark for differentiating the function, for a total of 3 marks. So now that we're on part A, we can move on to part B. Using the formula given in part A, with x1 equaling 1, find the values of x2 and x3. Well, first we can recall our formula that we ended up with from part A, which was that xn plus 1 equals 4x cubed n plus x squared n plus 1 all over 6x squared n plus 2xn. This is just what our final answer was from the previous question. And now, with x1 as 1, we can find x2 and x3. So if xn is 1, then xn plus 1 is going to be x2. So x2 is going to be 4, 1, which is x1 cubed, plus 1 squared plus 1, all over 6, 1 squared plus 2, 1. So I simply replace xn with 1, as x1 is 1, and xn plus 1 is 2, as 1 plus 1 is 2. And this, plug into your calculator, will give you 3/4. And that's x2. Similarly, we can do the same thing with x3, where x3 is going to be 4, x2, which is 3/4 cubed, plus 3/4 squared, plus 1, all over 6 3/4 squared, plus 2 times 3/4. Once again, plugging this in calculator will give you x3, which will give you an answer of 2/3. And that's it for this question. So you'll get 1 mark for finding each of them. So you get 1 mark for x2, you'll get 1 mark for finding x3. Now we're done with part B, we can move on to part C, the final part of this question. So we need to explain why, for this question, the Newton-Raphson method cannot be used with x1 equals 0. Well, first, to do this question, we need to really understand what the Newton-Raphson method is. So first I'm going to sketch out a set of axes here. So there's my y-axis, and there's my x-axis. Suppose we have some arbitrary function, f of x like this. And we're using the Newton-Raphson method to locate a root. Well, what happens is, suppose we start with this number here, xn. The Newton-Raphson method will go up to the point where the y is for the x value, and draw a tangent to that point, as such. And then, where it hits the x-axis again, that's the next value of xn plus 1. They'll go back up, hit that, and draw another tangent. And as you can see, it quickly zooms in on that root there. And that's how the Newton-Raphson method finds the root. However, suppose we chose this value here as our xn, our beginning value. Then what will happen is, it will go to where the y value is, choose that point, and draw a tangent. However, the issue is that this tangent that we have right here is completely horizontal, and so it won't actually hit the x-axis, which means that if we ever have a turning point, and we choose that as our starting value for the Newton-Raphson method, it can't be used. And we can see why here, as a tangent will be horizontal, and so never hit the x-axis to find the root. Mathematically, if we write the formula for it, xn plus 1 equals xn minus f of xn over f dash xn, which is just the Newton-Raphson method formula. Well, at f dash x of n equals 0, which is a turning point, then f of xn over f dash xn is undefined, as we have something divided by 0. Consequently, that means we can never use the Newton-Raphson method at a turning point, because it would just break. And so, let's relate this to our question. So, for f of x, which in this question is 2x cubed plus x squared minus 1, f dash x is going to be 6x squared plus 2x. And that means that for x1 equals 0, we have f dash of 0, which is going to be 6 0 squared plus 2 times 0, which is 0, therefore a turning point. And so consequently, the tangent that is made will be horizontal. And thus I cannot find a root. It will be horizontal, it will not meet the x-axis, and so not locate the root. And that's it for all of this question. Now it's just the 1 marker, so you'll just get 1 mark for the explanation at the end.